Manager process. Yes, this is again important one. It runs on both source and the target servers. You cannot avoid it. You have to run the manager process. The job of manager, it controls other Golden Gate processes and components. So like in manager process, what you can do is you can set auto starting of Golden Gate processes. Okay, let us assume somebody shut down the systems or there was a reboot of the server. If this kind of case happens, you as a DBA, you need to actually initiate all the processes again, right? The Golden Gate processes. So what you can do is in manager process, you can configure to auto start these processes. So you only start one process, which will initiate the other process. Same thing goes with the target side. So the job of manager is it controls the Golden Gate processes and components. Manager must run in order to run the extract and replicate. This is important, otherwise your port information won't be there. Okay. Many scenarios, I have read it online or I have seen it while the Golden Gate is running and you can shut down the manager and still the other components will not be impacted. I don't think so. Honestly, I never tried that kind of disastrous thing. Maybe in practicals we'll try to do it. We should do some crazy stuff as well. So we'll try to do that and we'll see what is the impact of bringing down the manager process. It actually maintains the communication port, stop the extract or replicate process only if it is configured. It is not automatic job. Okay, only if you configure it for auto start, then they will start. It generates the reports for the processes. Yes, in case of an error, it is actually the job of manager process to generate the reports that we see and debug the issue. Contains control parameters. Yes, there are a lot of parameters that you can use in Golden Gate which actually control your environment. So those kind of parameters we need to put into manager process. So we will, when we configure manager, you'll understand how it is done. And also it manages the trail files. Let's take again, somebody was just asking me. So to answer that question, let's take I want to have an auto delete kind of, what do we call that one? I'm not getting the correct term. I just want to clean up the source trails, retention. Yeah. If you want to have a retention policy on the source trail, that after 5 days, all the source files should be deleted. Those kind of retention parameters we define under manager process. So that way what will happen, it's easy to clean up the disk as well once the source trails are used. So we can generally keep it for 2 days, not more than that. 2 days or 2 GB is a good range. So you keep trail files either for 2 days or either for when it reaches 2 GB, you delete those trail files. So more on administration when we discuss about the Golden Gate administration, we'll talk about what all you can do with the manager process. Next is this great point, which is checkpoint. By the way, what is a checkpoint? Anyone, if somebody wants to take this initiative to answer this question, what is a checkpoint?
So Arun, it's a consistent state of any database.
Sorry, Kamal, I didn't get you.
It's Pankaj here. Arun.
Sorry, yeah, Pankaj.
The checkpoint. Yeah, it's a consistent state of any database.
Okay, that's a good one. Right, that is actually related to database, but I try to always go out of database. So let us look at an example that is completely out of the database. Okay, I'm just thinking which example would be good. Okay, we'll consider a highway, right? Okay, I don't know if this really looks like a highway. On a highway, when we go, at least in India, I don't know about other countries. Okay, we have toll booths, right? So these toll booths, let's take if a car is crossing this toll, or what do we call exactly? I don't know in other countries. This is a toll gate. Over here, we pay some money to these people in order to cross this one. This money we are paying just because for the maintenance of the roads. Okay. So let's assume we have 2-3 toll booths or toll barriers on the highway. This is your journey. This is like you start from here. This is your start, and this is your end of the journey. Now, assume that one car has crossed the first toll. I'll just mention it 1T, 2T, and 3T. So if it has crossed the first toll booth, then it simply means that the user or the guy has covered this distance on the highway. It's pretty obvious, right? If the guy has already taken the ticket over here, then we can say that from the start till this point, the user or the car has cleared. Now we did not get any update for a long time. Suddenly we see that the car passes the second toll. So we can happily say that the car has moved forward this much in time. Okay. So we can actually say that, okay, from the start point, current state of the car is over here. We are not sure about in between where the car stops or what happens to the car. We are just bothered about the stages. Now the car passes the third toll booth. So we can clearly say that car has at least moved this distance from the start point. And again at the end, I'll talk about end later. So at this stage, this is generally what happens with your transactions. When you start a transaction, that is nothing but how do I say? You have checkpoint 1 or the first checkpoint. So let's take the checkpoint 1 number is 1001. Then you move forward in time, or the transactions are being executed in the database. Then you say that checkpoint 2, and that might be 1002. This actually guarantees, when we talk about checkpoints, this guarantees that this much transaction has been successfully implemented in the database. This actually helps the database to identify or to actually maintain the consistency over the transactions that have been completed or over the amount of work that has been done. This would be CP4. Okay. And then once the transaction ends, this is nothing but, okay, let us assume we are committing the transaction. Okay, this will be again another checkpoint on the commit where, okay, I'm not talking about SCN. SCN is a separate case. So this is one great example to relate highway tolls with the checkpoints inside the database. So in general terms, what is a checkpoint? Checkpoint is the measure of the amount of work done inside the database. Okay, once again, checkpoint is the mechanism or the way to actually measure or put a check on the amount of transaction that has been completed. Now SCN is again a different story. Let's not get into SCN. Golden Gate checkpoints. Now, do you think Golden Gate should have checkpoints? Let us talk logically. We don't need to actually look at the slide. Do we think like there should be a checkpoint in Golden Gate? Yes. How? I'm taking a very vague scenario just to relate it to what I'm trying to say, you guys. This is my database redo. In redo, transactions are being written. Okay, but this was the last committed transaction. We are having transactions, but these are not committed. Okay, and then your extract process. The job of extract process is what? To observe, to just read from the redo and get the committed transactions. Okay, so we are assuming this committed transaction is written onto the source trail. Yes, who is it?
Here, this is Suman.
Yes, Suman, tell me.
It is not guaranteed that if you commit the transaction, it's not there is no need to go to redo, right? Sometimes it may resides in buffer cache also until some particular time. Right?
Now that is
the golden gate.
Yeah. Go ahead, tell me.
So the golden gate waits until it through to redo log.
I think that will be answered in the next slide, where we have integrated capture versus classic capture. So that is something like completely out of the scenario. Don't worry, it will be answered in the next slide. Any which was I
Okay.
don't think we'll be looking at it right now. But if you take my personal opinion, what is the percentage that your transaction will be in memory? It is very less. How? Because
Yeah.
when redo log, log writer writes data to redo log, it is like whenever the redo log is 1/3 full or 50 MB is used or a checkpoint occurs, right?
Yes.
These are
Yes.
the or user commits or whatever it is. So this percentage would be in somewhere point zero. So I think we are not going to talk about all this, but yes, maybe I'll explain you when we are in performance tuning, and also in the next slide you will get the 50% answer to that.
Okay. Thanks.
Okay, let's come back to the topic. This transaction was committed. Okay, committed extract. I'll name this transaction, or I'm naming the committed point as 1. Okay, so the extract will write this onto the source trail, correct? This is very simple. But extract is an observer. It is still observing the redo log to see the next committed transaction. We are assuming over here the user issued a commit. Okay, this is where what extract will do is it will use a checkpoint mechanism. It will assign a number to every committed transaction. Let's take, it is saying that it has created a checkpoint number as 123 for the first committed transaction. Now, while it was observing for the next committed transaction, suddenly it got a commit. Then what it will do is it will give it a number 124 and it will write it onto the source trail. So this checkpoint actually guarantees that this much work is done on the redo, right? It makes sense, correct? So again, relating it to the highway concept, when if extract is having the checkpoint as 1 to 3, it says that this much work is done. If it is 1 to 4, then this much work is done. Again, after some time, if there is another commit, this it will issue a checkpoint as 1 to 5. So this way it helps the extract process to not to extract the data from redo multiple times. So these checkpoints will help the extract. The same way, the same concept is used by all the processes. I don't know, in one of the interviews, one guy was saying only checkpoint is related to extract process, but every process uses it. So how? Now you have data pump process. Data pump will start delivering the transactions. So it has delivered the first transaction onto the target site. It will generate a checkpoint 1001. That means this much work is done. This much data has been transferred onto the other site. And when it is transferring the second or the next transaction on the target side, it will generate another checkpoint saying that okay, this much work is done. So that way it helps the data pump to not to send data multiple times over the network. Checkpoints actually define this much work has been done, and it actually guarantees that that much work has been done properly the way it has to be done. So checkpoint will only be issued when the transfer was done, it was collected by the collector process. Now, if there is a problem with the collector writing in the source trail, that is not the problem of data pump. The job of the data pump is to read and push the data. Also, it has to be collected by the collector process. If it is done, it will issue a checkpoint that guarantees that this much work has been done. Again, collector will have its own checkpoints for the amount of data it has collected and the ones which has been returned to source trail, target trail. From the target trail, again, replicate will have its own checkpoints, maybe 111, 112, 113, and those checkpoints will guarantee that, that amount of data is written onto the target server. Okay, too much of concepts, but actually I have a great link about checkpoints which I will send as a part of must read email. So make sure you're reading that email, okay, about the checkpoints. So now, I mean, I don't think we need to actually go through this slide because we got the real concept. Okay. Any which ways, while we are administering, I'll try to show you guys about checkpoints, but not really in the initial lessons until you guys get some stuff, until you guys actually, what do you call, try to configure Golden Gate. And later on, when we are getting more into the details, then you'll understand about it. Do we have to configure checkpoints for every process? No. Why will we configure? That is an internal mechanism. Do we need to solve the transaction? Okay. Like how we don't configure checkpoints in database or SCN number in the database, that is automatic, right? It is like the internal of the Golden Gate to make sure, okay, that much work has been done. Right, guys? So that's about the Golden Gate architecture. I mentioned earlier, please go through this video at least 4 or 5 times. Get your, so any sync between checkpoints among the different levels of processes, any time intervals between checkpoints. I'm not sure about the time intervals between the checkpoint process. Why? Because checkpoints are generated, I mean, after the amount of work is done. It is not based on the time in which it has to be done. Okay, it is like amount of work. So if one guy is doing some work in 1 minute, so you can tell that checkpoints occurs at every 1 minute, but the same work is done by another guy in more time, then for him the checkpoint time intervals will be different. So there's no time, it is not time interval bound, it is bounded by the amount of work. So if 10% is done, okay, example, let's take a contract, right? So we get into a contract of a building. So what I say is initially you will have to pay me 10%, and after every 10% of the completion of the project, you need to issue the money. So this becomes your checkpoints. Now, how much time does the builder takes to build the building, or between the percentage of amount, or between the release of the amount, that's irrespective. So it's like based on the amount of work. I mean, honestly, I did not get this much into checkpoints. So any sync between checkpoints among the different levels? Not really. Every process has its own checkpoints just to make sure it has done the amount of work. I think logically I'm correct. Excellent presentation. Okay, thank you. No one can beat you. Oh, okay, guys. I mean, let's not have these kind of things in the chat. If you have any personal appreciations, please send it in an email. Okay, yeah. Who's it?
Hey, Arun, this is Pankaj here.
Yeah, Pankaj, go ahead. Tell me.
Arun, first I'm sorry, I'm repeating my question, but last time I asked question about heterogeneous replication. So my question was a bit different. So I understand that if we have source or target Oracle, so we can perform GG. My question was that if Oracle is nowhere, either source or target, if source is SQL Server and target is MySQL or some other RDBMS, then can we also use GG, although it's a Oracle product?
Okay, you need to understand this. This product was not Oracle product; it is acquired product. Okay. If you understand the first thing, so over there, if you remember, this product was created for the Nscribe database, not even for Oracle. So this product was created for Nscribe to Nscribe replication initially, and then it has continued to add multiple database vendors. So I think that answers your question. It is not an Oracle product; it is acquired by Oracle. So if it is acquired by Oracle, that means it is not developed by Oracle. If Oracle is developing, I know Oracle is obsessed with its own products, and it will always be Oracle product centric. So, but this is not.
Okay, thanks, Arun.
No problem. Yeah. Does GG support NoSQL DB? I think I did not hear about this one. Maybe you need to check the certification matrix. I think it does not support, as far as I know. No, it does not. I have never heard of Golden Gate on NoSQL. It does support timestamp. I think the ones which we have seen earlier, those are the ones those are supported. Maybe in the upcoming releases they might think of adding it. Okay. think of adding it. Okay guys, not to waste a lot of time of other people, because everybody is in the mood of weekend. So let's quickly complete this slide. So rather what I'll do is I'll explain the concept, and then I don't think we'll have to look back this slide. So let me just talk about the idea. Okay, we developed our own replication product. Our replication product, this is SourceDB. Now, please pay full attention, and this is very important, and also very important interview question. We have source database, and in our application product, we are developing ABC Replicat. This is our product, okay? ABC Replicat. In our product, we are having the capture process. The job of capture process is to read the archive logs. Just an assumption. We read from archives, send it on to target. Now there is a performance issue. What is the performance issue? Archives will be generated only when there is a log switch or you forcefully do a log switch. That's the general case, right? So understand in the redo logs. While the redo is generating, the transactions are very slow. So the log switch generally happens in 10 to 15 minutes. Just some vague scenario. So if the archive is not generated, first of all, we have this 15 minutes lag. Okay. Plus our capture will take some time to write into source trails, correct? And then source, DP will read it. DP will send it on to the target. We have collector. Collector will give it to replicat. Replicat will apply into the target DB. This is the general case scenario. Now this 15 minutes plus some time for the capture, some time for the data pump to send, some time for the replicat to apply. So let us assume it is coming up to 1 minute. Just some rough calculations. So total time for your transaction, one guy issued a transaction and it will be reflected onto the target system in 16 minutes. This is a big problem. What if the archive is not generated? What if archive is further delayed and there was no log switch? In this kind of condition, what we do is we got a problem from customer. They say that, come on, ABC Replicat, your product is waste. So what we do is we get into the performance tuning of the application or our own product. We want to reduce this time. That is the customer goal. What we do is rather than reading from archives, we'll move the capture process to read directly from the redo logs. Correct? Now in that one also, there will still be a little lag. We have transactions that are running in the database, and log writer is taking little time. I mean, it does not take so much time. It is taking little time to write into the redo logs. So what happens over here? Again, there is a performance issue. A user is complaining like, no, I want real time. I mean, the way I execute the transaction, it must reflect onto the target. So this will again add up some amount of time. Again, your capture will have some time, data pump will add up, collector will add up, replicat will add up, which will, we are assuming it is coming to 1 minute. Okay, in 1 minute, the transaction, when it is executed on the source, within 1 minute, it is reflected onto the target. But client says, I don't want to wait for 1 minute. What can be done? So what we decided to directly take use of the log writer to capture the transactions. But there is a problem over here. If I do like this, we are increasing the load on the log writer. Now the log writer job is to write it onto the redo log files and also send the data to capture. So this is the reason. What happens is there is another utility or another service. Sorry, there is no utility. It's a service. There is a log miner service. This service is a separate service inside the database, And the job of this service is to directly read the in-memory redo transactions. It will read those transactions, send it to capture process. Now understand, we are not disturbing the log writer. Log writer is free to continue its work. Redo logs are generating on time. Archives are generating on time. Log miner service is activated inside database, and this service will send LCRs, logically captured record, or logical capture record. I think that's what we call it. Maybe it's the right term. I'm just doubting it. LCRs is logical capture record. Yeah. So it will capture these transactions, send it to the capture process. Capture process will continue to process. Now, the benefit of this approach is the client's replication time is reduced to 2 seconds. This is one big performance tuning activity which I have shown you, and this is how Golden Gate has evolved over the period. So we are not ABC Replicate, we are actually the Golden Gate. So Golden Gate, initially it was for archives, then it moved on to read logs, then it tried to move on to log writer, but there was a performance issue. Then they introduced this new service called log miner service, which is auto start. You don't work with this service. When you configure a capture, it will work with the log miner service and it will be an auto start. Okay. This method, or okay, I'm just searching for a right term. This is your, I'll actually name it as redo log buffer. Understand, this is the instance, this is redo log buffer, and then we have log writer. Correct? Log writer will write into redo logs, and from redo logs archives will be generated. Now, if we are reading from archives, or sometimes even if we are reading from the redo logs, this is known as classic capture. Okay, once again, if I try to read from archives and redo logs, this is known as classic capture. And this was the earlier case with Golden Gate. So now we know the problems of reading through this one, right? There might be a lag which is imposed by the source. That means if you're reading from redo logs, there might be a lag, right? Same way there might be a lag in the generation of archives. So if you are capturing from the redo or archives, this is known as classic capture. But if from the redo log buffer, we have log miner service. Understand, this is a service, this is different than your log miner utility. Again, these are not the same. From log miner service, we capture the transaction. This is known as integrated transaction. Sorry, integrated capture. So what's the difference? If you look at the idea about these two, we have moved close to the database. I'm sorry for that zigzag. So we have moved close to the database. So what is the benefit of moving closer to the transactions or closer to the database? The lag will be reduced. Okay. So Golden Gate actually supports two types of capture. One is integrated capture, another one is classic capture. We'll be looking at integrated capture because it is used in most of the environments. Classic capture is less used. So I'll tell you the difference, how to configure. There is only one word that you need to include and it will convert into classic or integrated. But all our practicals will be on integrated capture because this is something which everybody uses. Again, there are further, in some environments, we have seen that this log miner also creates some trouble to the DB performance. At that point of time, people actually switch to the classic capture because this one is better and then performance is restored. It is very rare to have this kind of situation. But again, it depends on the environment to environment because see, initially we had the classic capture, and again, I'm using the same word. If you talk to old people or maybe the people who are working for a longer time in Golden Gate, and in case if you join a company where they are using Golden Gate, you most of the time tend to see a classic capture. So don't try to give an idea of integrated capture until you understand why they really configured the classic capture. Is it because they have limited knowledge, or is it because there was some performance issue in the database? Only when if there is any issue and they have switched to classic capture, don't touch it. Otherwise, if this was configured because the limited knowledge of your seniors, go ahead and show them the benefits of integrated capture, and then maybe you can take it as an assignment, right? So this is about integrated capture and classic capture. I think we don't need to run through the slides. Maybe once I publish the recording, this slide would also be available for you guys. And that's an high level thing. I mean, high level idea about what is classic capture and integrated capture. Which one is the default capture process? Classic is the one. For for integrated, we need to supply one additional parameter. Yeah. So as I said, while we are configuring, I'll let you know how we configure both of them. Don't worry. It's just one word which will change it from classic to integrated. Right, guys? Sorry that I have taken so much time, but I think we were on time, right? Not on time. I've actually taken 30 minutes. So one last thing before we wind up today's session, because we will be meeting again after 5 days, right? Probably, yeah, 5-6 days. So in the next session, I'll be sending you guys one link, okay? Maybe on 24th or 25th. Those are the links to download the VMs which I will be using. So the same VMs I want everybody to use. We all should be in sync because we are learning Golden Gate. So we must replicate, I mean, you all must replicate my environment on your systems, right? So that's the reason I'll be sharing these VMs. Make sure you download them. It is, I mean, the files are pretty big. It will take good time. At least I'll send you guys 24 hours prior to our next session, maybe until 25th or 24th, somewhere in these 2 days, I'll send you the download link. So try to download, but don't play with it. Just keep it over there. Do not even try to open it, what it is. Don't do anything. Download, keep it, wait for the next session. I'll tell you what has to be done, and then we'll proceed further. Okay. And also what softwares are to be downloaded, how to be downloaded, everything we'll be looking at those things. So no, don't hurry up. You know, sometimes it happens. That is my tendency also. When I want to learn things fast, what I do is I move ahead of the trainer. I'll try to do everything, and then I come to know that trainer was on a different track. So don't waste your energy. Just do the I mean, first thing I would recommend is revise the videos again and again. You have 5-6 days, revise them. Second thing, what I want you to do is, if I give you an assignment, try to do it. The third thing that I want you guys to do is, I continue to send must read emails every day. Okay, if I find something that you must know, and if I send you an email, it might contain 1 or 2 links. Please read it in a day. I mean, don't tell me you don't have time to read at least 1 email. Just take out time for this one, and then I think we all will be on track. Right, guys, so I'm done for the day. If you have anything before we wind up the session, let me know. Okay, so if nothing, then we'll continue to meet on the next weekend, right? Okay, guys, so if you have anything, send me an email. Till then, take care. Have a good weekend and also good week ahead. Thanks. Bye-bye.